In this video, we're going to start to explore some of the techniques that let us solve problems efficiently. Specifically, the idea of divide and conquer, which means taking a problem and cutting it into smaller pieces of the same type, cutting those into yet smaller pieces, and so on, until the entire problem has been broken down into very simple steps. So here is another classic puzzle. It's called the Towers of Hanoi. It was invented by a French recreational mathematician who had almost certainly never been to Hanoi. If it had been a Vietnamese mathematician, I assume it would be called the Eiffel Towers instead. We have 3 pegs and we have a bunch of disks. And we want to move all the disks from one peg to another. But there are rules. We can only move one disk at a time, and we may never place a larger disk on top of a smaller disk. So how are we going to do this? So here is a sequence of moves that achieves this. It's clear that at some point we have to move the largest disk, but by the rules of the game we have to first move the smaller 2 somewhere else in order to do that. So we can describe the overall puzzle of moving all 3 disks in a broken down way. First move the smaller 2, then move the largest one, then move the smaller 2 again on top of it. Of course, how do we move the smaller 2? Well, that would consist of moving the smallest one, then moving the medium one, and then moving the smallest one on top of it. So you see, we're breaking down the puzzle of moving 3 disks into the puzzle of moving 2 disks, and then the rather simple puzzle of moving a single disk. If we break all this down into a tree of moves, we get something like this. This is what we would call a recursive algorithm, and this notation, Hanoi 1, 2, 3, means, for instance, move disk number 1, the smallest, from peg 2 to peg 3. And so you see how this tree breaks the puzzle down into smaller pieces. There's a nice way we can do this with modern programming languages, which is as a function which actually calls itself. So this is a recursive function. It takes a couple of inputs, n, how many disks we're trying to move, and I and j, which peg we're trying to move them from and to. And then if n is 0, if you're trying to move 0 disks, it does nothing at all. It's done. However, if n is not 0, it moves n minus 1 disks from peg I to peg k, whatever the other one is. Then it moves that largest disk, and then it moves those n minus 1 disks back. So this is a function which calls itself until it gets down to what we call the base case, where the problem is trivial and there's nothing left to do. As it calls itself, n will get decreased at each level of recursion until n is 0 and there's no work remaining to be done.